Okay, everybody, this video is going to be about making our target, which is right here, move. And not just move around the screen, but also bounce off the edges. So what we're going to do is we're going to be modifying our coordinates for the center of our ellipse, and we want to be making it decrease in both the vertical and horizontal direction. And we'd like to do that at the same time so it could move in some interesting diagonal patterns. We'd also like to make sure that we can easily bounce it off the walls. So let's make that happen using some very famous code that's in a lot of 2D video games. I'm going to make two new variables, a Vx and a Vy. If the x and y represent the position of the target's position, then the Vx and Vy will represent the target's velocity. Spelling is hard, apparently. And this is going to be sort of a change in x. It's going to be how much we're going to be adding or subtracting to x every frame. Same with Vy, it's how much are we adding and subtracting to the y coordinate. So these numbers will be relatively small, and they will even a value of 5 or 6 will appear to be a pretty big change because the frame rate is pretty fast. So we'll be adding this number 60 times a second to this number and vice versa. So let's take a look and see how that works. So the movement code basically is this: x equals x plus vx, y equals y plus vy. If we take a look at this game, the target still doesn't really move, and that's because Vx and Vy are 0. We're adding 0 to our x and y coordinates, so they're not really changing at all. And that makes sense, because a velocity of 0 means you're not moving. So let's change a few things in our setup. Maybe we can initialize our Vx and Vy, and we'll see how it works. So if we set Vx to, say, a positive number, 3, it's going to move which direction? Well, we're going to be adding to its x-coordinate, and the way the number line works means it'll move over to the right. And just to confirm that, let's see if a Vx of positive 3 makes it go that way. It sure does. Every frame it's increasing its x-coordinate. Whoa, it's gone off the screen. That's all right. Just to demonstrate, negative 3 will move the other direction. Awesome. And if I was to change this to, say, negative 1, what would you expect to see different? Well, it'll still be moving to the left, but it'll be moving slower. So the magnitude of this number will represent how fast it's moving, and the positive or negative aspect of it will mean if it's moving to the left or right. Let's set that to 0 and just look at Vy. Vy is a little bit more confusing because if I say 3, you might think, well, it's going to go up by 3, but actually it goes down because of the y-axis being upside down in processing. So you have to make it a negative number in order for it to go up in processing. And most programming languages, whoa, look at it go. It's going up. What direction do we and what speed do we want it to go at the beginning? That's a good question. I don't really have an ideal thing, but I kind of think it might be fun to shake it up a bit, make it sort of random so that we don't know what direction it's going to start in. So you can use the random function, which returns a value between this range, a random value. So it's not going to be negative 3 or 3 necessarily. It might be, but it will probably be some number within this range. Well, definitely be some number within this range. It'll be a float, which means a decimal number, like, could choose 1.75, for example. And I'll do the same thing with Vy. There is some limitations to this. I might get 0, 0, which would be a pretty boring speed. It wouldn't be moving very much. So that picked that particular speed this time. Second time I run it, it picked that speed this time. Fantastic. Now it's going to pick that speed, so it's random. It's moving in an unpredictable direction. So, what next? So we have it moving, and you know what? This code is doing it all right here. This movement code, it's pretty fabulous. We can add in a couple more lines of code to make it bounce. So let's just think about what happens when a target bounces. It's going to go off. If it were to bounce here, it would have come off and continued to go down. It was going up, and when it hits the top, it's going to bounce off and then go down. What changes in that bounce? Well, if it hits the top or the bottom, the only thing that really changes is its Vy, its vertical speed. It continues moving horizontally in the same direction, but the vertical direction flips. So to do that, we first check to see if we hit a top or bottom wall. So I can say if x is, say, less than 0. Oh, no, sorry, y is less than 0. That's the top. Or, and this is the or symbol, these are pipes. It's right above your enter key. It's like shift and backslash. It gives you these pipes. So, or y is greater than height. Then I basically want to just flip my Vy. If it was positive, it becomes negative. If it was negative, it becomes positive. So you can write it like that, or you could write Vy equals Vy times negative 1. So if it was 3, it becomes negative 3. If it was positive 2, it becomes negative 2. And you'll see that works out pretty nicely. I don't know if I'll get a vertical. Oh yeah, so here it's coming in. It's going to hit, boop, and it goes off, and it continues on. So you can see how it's all that matters was the y velocity. Oh no, it's left the screen. We better get a similar thing going on for x. So if x is less than 0, or x is greater than width, then it's going to be the Vx that we're going to flip. So that'll work out nicely. Let's see how that looks. We'll start it up, and we should see it bounce off the edge and continue on. We'll see if it bounces off this edge. There's a good chance that this will work, I hope. Oh, here it comes. Yeah, it did. So this target is now nicely trapped inside of our screen. So what's the story here? Basically, we're done. One last thing to mention, it might be nice to stick in our radius here. Instead of hitting at 0, because that's the center, we don't want the center to collide with the edge. We'd like the edge of the circle to collide with the edge of the screen. So I'll put in my radius here instead. And then I could subtract my radius from the other side, so I hit a little bit sooner on that side, and we can see some nice bouncing going on here. Oh, off it goes. Is it going to hit on the very edge of the circle? Yes, it does. All right, nice. And you can check to make sure that works in all the other directions as well. So there you go. There's movement and bouncing, and thanks for watching.